On the homework, watch closely. I'm going to do some stuff real quick on this. I know 17 through 24, they ask you to like find the perimeter of this shape or that shape. First thing you should do, or first thing I'm going to do with this picture, is I'm going to go through and I'm going to find the lengths of all the different segments that are in this picture. And I'm going to do this extremely quickly. Let's do AB first. I can't see that, can you? How about there? Can you see it there? Yeah.
Bright green, like you guys.
Do white.
Or white.
White.
Didn't like it.
Dope. White sucks.
Oh. Hey, keep going. AB. AB. We set it up. I'm going to set up one. Probably can't see it on the white though, can you?
No.
Nope.
It is homework last night.
Last
Why
night.
don't you just write it with your markers?
Because that doesn't record us.
Oh, it actually records what you're doing on the board too.
So if I look at AB.
Oh, I thought it was recording your voice.
No, it records everything.
So it records your voice and what's on the board? It's recording you. So here's you recording you.
So if we do 0 minus -5, that's why she kept talking. She's,
I didn't know it was recording you.
4 minus 3. 0, we change this to plus. It's 25. It's 5 squared. 4 minus 3 is 1. Have your calculators out so you can help me. That's 1 squared is 1. 25 plus 1 is 26. What's the square root of 26?
5.04. I'm just saying that because of how it was 144.
5.09, so 5.1. 5.1, can you see that right there? So that's the length of segment AB. And you could use the distance formula on all of these. I'm going to do a lot of it in my head. Just keep your calculator out so that you can help me. On this one, subtract them, that's 4, that's 16. 3 minus that is 4, that's 16, that's 32. Somebody help me out, what's the square root of 32?
5.65.
So 5.7 we'll say. Next one, what's nice about this one? Close.
It is 1, 2, 3.
It's vertical. All you got to do is what? Count squares. 4. So we know that one's 4. That was easy enough. Let's do this little one here, ED. Again, if we do the distance formula, if I was to set it up, I'll set it up one more time. For this one, we do 4 minus 2 squared plus our y is -3 minus a -5 squared. Change that to a positive. 4 minus 2 is 2. 2 squared is 4. -3 and 5 is 2. 2 squared is 4. 4 plus 4 is 8. Somebody help me out. What's the square root of 8? 2.8. Close enough. We do this one from -2, 1. If we do from F to E, so segment FE, what is that? That's 416. That's 416. That's 32. Square root of 32. You guys told me it was 5.7, right? Is that right?
It's the exact same length.
So what do we know about these two? They're the same. All right, and then they probably are parallel. Let's do this one. AF, segment AF, -5 minus 2 is -3. -3 squared is 9. 4 minus 1 is 3. 3 squared is 9. 9 plus 9, 18. Somebody help me out. What's the square root of 18?
4.24.
4.24.
That'd be a negative.
Now, is it going to be a negative?
No.
All right. Then we got to find these two, right?
Yeah.
0 minus -2 is 2. 2 squared is -2 squared is 4. 3 minus 1 is 2. 2 squared is 4. That's 8 again. What was the square root of 8? 2.8. So that's length of that segment.
And the other side's the same.
Same thing. 2.8. Now, once we know all those lengths,
Now we can just-
now can we answer the questions that they ask?
Yes.
And that's what you should do. A lot of times in geometry, this is the way things need to be done. All right? Or Kelsey back here, she says, well, I'm only going to do what I need to do. That's not the way it works in geometry. All right? A lot of times you do a whole bunch of work and then get your answer.
And then you gotta do more.
Okay?
I give props to people who are really good at math because it's a lot of work and I can't keep all the steps together.
Yeah, you can. I have faith in you. So, what's the first question that they ask us? 17.
Find the perimeter of CDE.
CDE. So CDE, that's right here. That's this triangle. 4 plus 2.8 plus 2.8. So what? That's 5 or 5.6, 9.6. Is that about right?
9.66.
9.6, somewhere around there. Close enough. Now, since I rounded all this off, would I take off a bunch of points if you were a tenth or 100th higher or lower than me?
No.
Probably not. What's the next one? What's 18 ask?
Find the perimeter of rectangle BCEF.
So that's right here in the middle. 2.8 and 2.8, that's 5.6. 5.7 and 5.7 is 11.4. 11.4 plus 5.6 is what, 17?
I got 12.1.
Now, would I take off points for 12.1?
Yes.
Yeah, it seems like you forgot to add something in. Maybe you forgot to add in a 5.7. What 19 ask?
Find the perimeter of ABF.
ABF, that's this other triangle. 2.8 plus 4.2 is 7, plus 5.1, about 12.1. Does that seem about right? What's the next one asked? What's the next one? 20?
Yeah.
What's it ask?
Find the perimeter of quadrilateral ABC.
ABCD.
Yeah.
ABCD. So they actually want the perimeter of this entire shape. So we'd have to add up 5.1, 5.7, that's 10.8, 12.8, 15.6, 21.3, 25.5. Does that seem about right? Yes, no, maybe? Can you do all that in your head, Ginger? Am I confusing you? Don't lie to me.
Yeah.
So I should go slower. Does everybody understand the main thing here? Does everybody understand how to find, using the distance formula, how to find the lengths? Yeah. All right. So
Can we go through this whole thing because I'm pretty sure I was just confused a bit.
we're gonna go through a bunch more. Did you understand the distance formula?
Yeah, I understood the distance.
Next thing, 25. What's 25 say?
This 25, 26, try to correct the error and finding the perimeter of the area. Find out what they messed up.
So they said the perimeter is 14. Where did they mess up at? How wide is that shape? What's the width of that shape? Nobody knows? Can't count?
P equals 2L plus.
How many spaces wide is it? 5? All right. How tall is it? Let's go that way. Doesn't look like it. they mess up on? They counted wrong. Instead of 4, it should have been 5. Next one, 27. What's 27 ask us?
Determine which point is the remaining vertex of the triangle with an area of 4 square units.
So we want 4 square units. On something like this, because I know they put a bunch of stuff like this on that end of course test. If they give you a graph and you're allowed to draw on this and they tell you these 2 points, can you just sort of guess and put a point in here somewhere and try to figure it out and at least give that answer if that's close to being 4 square units? And that's sort of what they want you to do here. Right? Now, they give us those 2 points. What I would do, I'd graph those 2 points. Don't make it harder than it is. What are the 2 points? So I just sort of graph them.
-2 for x.
-2, then what?
1. And then
2 and 1. So we already know that from negative, that's -2, 1. That's 2, 1. We already know how long is that? How far is it from -2 over to 2?
that's 4.
4. So we know that that's 4. Right? What's the formula for area of a triangle?
Base times height. 0.5.
Base times height divided by 2, something like that, right? So if we know this is our base, it's got to be 4. So we want 4 times something divided by 2 that gives us 4. What's going to fit in there for h? Just thinking it through. 2. 4 times 2 is 8. 8 divided by 2 is 4. So how tall do we want it to be? 2 spaces, right? Just down 2. If we go down 2 spaces from there, what point are we going to be at? We're still out -2, right? Now where are we at? -1. Is that the only answer? Could we have went this way and went up 2 spaces? Could we have went over to this point and went down 2 spaces? This one and went up 2? So there's 4 different answers you could have had there. I'm not even sure, is -2, -1 one of the answers that they gave? Because I think this is multiple choice, wasn't it? So we got lucky.
I just want to say, like, the one thing I really do like about math is how it has a lot of other solutions for you to just be like, no, I don't want to do that. I'm going to do it this way instead.
So there ain't nothing there, and there's nothing wrong. You'll never. I might, if you give me an answer and it's pretty close, I might say, all right, Peyton, how'd you come up with that? But I'm not going to mark it wrong if it's, close to what it should be. Next one, 20. Oh, it wanted what?
21 to 24, 21 through 24. I just started that.
Oh, did I skip some?
Yeah, you can.
Find the area of CBE.
Especially if I don't
Oh, so it wanted area for that shape that we were on?
Yeah.
So give me one of them. What shape does it want us to find the area of?
Find CBE.
CDE.
Find the area.
So they want the area of that right there, right? If this is the same as this is the same as this, what kind of shape is this middle shape? Rectangle. So what do you know about this angle right here? Right? What do you know about that angle right there then? Right? So this is going to be the height. That's going to be the base. So what's the height of our triangle this time?
2.7. Oh, 2.8.
I got 2.8, 2.7, either one. What's the base?
2.8.
2.8. Somebody help me out. We probably want to change this 1/2 into what?
0.5.
0.5. Somebody multiply that. 0.5 times 2.8 times 2.8.
What is he? You didn't even give me time to type it in the calculator. I type it in real fast.
What is it?
You typed it in all these documents.
2.92.
I was trying.
2.92. Does that make sense then? 30.92. 3.92.
Yeah.
Ah,
I got 4, but whatever.
4 is pretty close, right? Does that make sense then?
22.
Yeah. Solving these equations. Anybody have trouble solving these equations?
Those are fun.
Maybe the only one that you maybe have trouble with is this one. What do you got to do first on this one?
You gotta get rid of that divided by.
Multiply by 2. Now, where you got to be careful on this one, when you multiply this side by 2, you
Gotta do both sides.
got to put parentheses around it and do everything over there. Multiply the whole thing by 2. That was the easiest part.
That was my favorite.
Yes. Could I have cross multiplied?
You could have. So if you want to put this over 1 and cross multiply this way, notice what you got to do here. You're multiplying that whole thing by 2, so you're still multiplying 2 and putting the parentheses around that, and this is just times 1, so it's x times 1. These two cancel out, so it's doing the same thing.
What about x equals 1?
X equals 1 on that one. Everybody agree with that?
Here.
On your protractor, look at it real quick. On a protractor, just to show you how to measure on a protractor, just very, very quickly if you don't know. You're measuring angles, and these are in degrees. All this is a degree. When you're measuring, it's got 2 different sets of numbers. So when I'm measuring an angle, first thing I'm going to do, I'm going to put the point of the angle. An angle looks like this. It's got 2 rays, and it's got a point. That point's called the vertex. I put the vertex right there at that hole. One of the sides of the angle, I line up with this 0. I can't line it up very well. With that 0 and that line across the bottom. Some of them have lines all the way across the bottom, some of them don't. The other angle, or I'm sorry, the other side of the angle, I don't want it to be going down here. That's off the protractor. To be able to use our protractor, to be able to measure it, the other part of the angle has got to go up through the protractor. All right? Now, when I'm looking at this, what you're going to have to remember when you're measuring these angles is the different kinds of angles that you have. You have acute angles. Anybody remember what an acute angle is? Smaller than 90. You have an obtuse angle. What's it? Larger than 90. You've got to look at your angle first and decide, is this acute, is this obtuse? The angle that I drew, acute or obtuse?
Acute.
Acute. So when I go up here and I look at these numbers, I should get a measure of something less than 90. So I'm not going to go up here and say, okay, this angle is 122. That doesn't work because that's an obtuse angle. You're going from here and around, and what you're doing is you're using that set of numbers that starts with 0. So we're using this set of numbers. We get to 50, we go past 55. This angle looks like it's just a little bit past 55, so how many degrees would it be?
56.
Maybe 56 degrees. All right? Now, if you turn the protractor around and you got it upside down or whatever, does that matter? No. All right? So even if your protractor's on here and it's like this and the numbers are backwards, can you still measure that angle and should you still get 56 degrees? Yeah, and that's why they have 2 sets of numbers on there. All right? So it doesn't matter how the protractor is or how the angle is in relationship to the protractor. Yeah, we're supposed to, unless I forgot to run this off.
Says I'll fix it. Why is your clock so messed up?
All of it.
Like the whole school is. It's because they're working on the electrical.
Working on
It's 11:50.
I swear I ran those off. Oh, they're on there. They're on that packet. I thought I ran them off separate. What I want you to do, measure those. There's actually 7. I think I says 6 up here. Measure them. Try to measure them real quick. Take about 5 minutes. Write each one. When you write it down, when you write your answer down, just write it right in the angle. So if this angle, if you measure it, and it comes out to be 122 degrees, write 122 degrees right in the middle of it there.
You must do a little like circle like that.
The degree?
Yeah.
Yeah, so use that.
Oh, not that little circle thing, like the little like hill.
Oh, this in the angle?
Yeah.
It's not necessary. We're going to do that at some point today, but it's not necessary quite yet. Somebody show you to do that in the past? Why did they show you to do that? Was there a reason for it?
I forget what it was, but yeah, there was.
When we mark them with those little half arcs like that, what that's actually doing is telling us that they're congruent. This point right here, line it up with the point, so the two come together. Line this to black line up with one of the sides, like that. Go up here. That was an acute angle, right? So we want the smaller number. So, not 50, is it? Something like that. See my geniusness? Do you want me to turn it off so you can do something silly? That's accurate. You made it.
I got an idea on that one.
Definitely did it.
On this, so if we go to measure these, I was just back here and Kelsey was measuring hers and she measured it completely different than what I'm measuring it right now. She was on this side. Does that matter?
No.
No. So I line up the vertex with the hole, line up across the bottom here with that, go up here. Mine looks like it's about 47 degrees. Anybody agree with that? Somewhere close to that?
Yeah.
48?
I got 49.
49? That's pretty close. Within a couple of degrees, probably be all right. I go to measure this next one. Somehow I line it up like this. Notice, line up one of the sides with the black line. The other one's got to go through the protractor. Line it up, line up the hole, line up that. Looks like that one's about 90 degrees. So what do we know about it? It's a right angle. Come back. Before I even measure this one, what can you tell me about it?
It's
It's an obtuse. So when I use my numbers this time, I should be using the bigger set of numbers. Should be more than 180. I line it up. Looks like something like that. I look like I'm at 50. Is 50 going to work? No. So what should I be looking at? About 130 degrees. Is that pretty close?
Yeah.
Now, can we answer the question, is my protractor precise?
No.
It's a good answer. I know Dawson's, his grade's already fallen.
Yeah.
We look at this next one. That one comes out at 150. Can that be 150?
No.
No. It's the other number, about 30 degrees. Anybody else get that? 29. Now, if you look at mine, yours is a little more precise because what does mine not have? It's got the little single degree marks. It doesn't have that. I wouldn't spend the time to try to draw each one of those
Oh,
on
but
here.
yours is precise.
All right.
I guess.
This one might be a little more precise, but the bad thing with it is, well, up here I could use it, I guess. But if we were on a piece of paper, I couldn't see through it. All right, so this one would be a little more precise maybe. So if I used it there, looks like on that one, instead of 47, looks like I got about 48 degrees. Was that closer to what you guys had?
That's what I got.
So I probably should have used this one. A little more precise. My son actually made that one for me. He's a little more creative than me. The other two, what'd you get on the other two? Because I don't have them. They got
You got 4 from up there, so the other 3.
all the other three.
I got 122, 79, and 90.
122, 79, and 90. Close.
121. I got 120, 80.
Pretty close.
Any items we need, right?
All right. Start copying this down. Angles. We're going to move extremely quickly. 12:18, right? So we got 20 minutes. Angles. Just write down that title. Angles. That's the title for the notes today. Angles. Do I need to say it 5 more times?
No.
Angles.
That's one.
Oh, you will. Be able to name angles. We got to be able to name angles. We talked about naming segments, naming rays, naming lines, points, planes, all that stuff. Angles, probably the hardest thing to name that we'll cover all year long. Be able to measure angles. We just did that. Be able to classify angles. Classify angles. Obtuse, acute, right, straight, so on and so on. Use angle addition postulate. Angle addition postulate is just like segment addition postulate. Bisect angles. Anybody have a guess as to what bisecting an angle does? What bisecting a segment do? Cut it in half. What do you think bisecting an angle does? Cuts it in half. Be able to find angle measures. Lots of equations. Lots and lots of equations. You got to be able to set up all these different equations and know, hey, from this picture I know that this plus this equals this. Or these two are equal to each other. Or whatever it is. Whole bunch of stuff. Can you read any of that?
Yeah.
No, it's a side table.
I cannot.
Try to write what you can. I'll try to make it better, but I don't know that I'll be able to.
There we go.
May I stand up here, buddy?
Yeah, you can move.
I like your antique light. Oh gosh, that's very bright.
No, there's no disadvantage.
That help out any? Usually I'll set that back here on the back table. It helps out a bunch, but. Hey. Hey, hold that. Sides. Sides of an angle. When you draw an angle, these sides. What is that? What kind of shape that we already talked about? What kind of, it's a ray. So you got two rays. They come together, they share one common point, their starting point or their end point. They share that. The sides we name as rays. Ray PK, ray PG. This point where they come together is called the vertex. Very important that you know that that point right there is called the vertex. Say it again, vertex, vertex, vertex. You got to remember it, all right? Very important. Vertex of an angle is probably the most important part of the angle. Got to be able to find that. Exterior of an angle, stuff on the outside of the angle. Interior of an angle, stuff on the inside. Nothing hard about this. A lot of common sense stuff, right? If I ask you to name the sides of an angle and you put segment PK, am I going to mark it wrong?
No.
Probably not. Should I mark it wrong? Yeah, it's probably not the exact thing that you should put, but I probably wouldn't mark it wrong as long as you put PK and PG.
Hey, fix the clock.
Yeah, it fixes itself at 12.
Is it really?
Yes, it does.
Next, naming angles. 3 different ways to name an angle. 3 ways to name an angle. These are very, very important. First of all, an angle symbol. Guess what the angle symbol is? A little angle, just like everything else. It's just a little angle. The angle symbol goes out in front when you're naming it. Instead of on top, like segments, rays, and lines, the angle symbol goes out in front. If we're looking at this picture, 3 different ways we can name that one angle. So Dawson could name it one way, Sandra could name it another way, Harry could name it a third way. And I got to know all 3 ways because all 3 of them are right. The first way, we could just name it according to its vertex. So angle with the angle symbol, P. That's one way. After you write this down, I sort of want you to do that. If there's any opportunity that you can name it any other way than that way, then name it a different way. I do not like the fact to name it with one letter. Because, and I'm going to tell you why here in a second. All right? Another way to name it. If they give you a number inside the angle, on the interior of the angle, close to the vertex, then we can just name it with that number. Angle 1. Later on in the year, we'll do that a whole bunch because we'll have 15 or 20 angles in a picture. We don't want to have to name them all with letters. So you go angle 1, angle 2, angle 3, angle 4, angle 5. The third way, this is the best way to name it because there's no confusion this way. You name it using 3 letters. This letter, the vertex, and this letter. And you just like you're walking around the angle. So when I walk from here, what letters do I hit? So guess how we name that? KPG. Angle KPG. The other way. Peyton's over here and he's walking this way. What? He hit G, then what? P, then K. Alright? Either one of those is fine. The vertex letter has to be the middle letter. That's the most important thing here. The vertex letter has to be the one in the middle. Now, the reason I don't like this one, if I draw this in here, we got another ray in here. And you name that angle P, and I ask you to measure angle P. Which one are you going to measure?
You can get 3 different answers.
There's 3 different answers there. We can't name it angle P once there's more than one angle in the picture. So that's why I don't like naming it. You can only name it with one letter when that's the only angle in the picture. All right? So it's better off to name it with 3 letters or with a number. Which question, Dawson?
Last year, when I was in Browns, I saw like just 2 letters on the ends, like just K and G.
They just use those to name it? Really? Shouldn't. Name me an angle in that picture.
Angle
Angle
A,
2.
B, F.
Angle 2, angle ABF. What do we know about angle 2 and angle ABF? Same angle. Same angle. Name me another angle in that picture.
Angle 4.
Angle 4, I heard.
Angle 3.
Angle 3.
CBD.
Angle CBD. Angle CBD is the same angle as what other angle? Angle 4. All right? Or DBC, right? Going the other way. Same angle. 3 different ways to name it.
Yes.
What can you tell me about if we measured this angle right here?
It's the same as the one obtuse angle.
It's the same as, it's obtuse, that's true. It's the same as the one over there. Does anybody know what those kind of angles are called? Close.
A reflection.
They're called vertical angles, and we're going to talk about that later on. Vertical angles. Learned about last year?
Yeah, I just don't remember.
Classifying angles, classifying angles. First one, acute. How much is an acute angle? Or what do you know about an acute angle?
It's under 90 degrees.
Under 90 degrees, that's wrong. All right, under 90 degrees is wrong. That's what you've learned up to this point. The reason it's wrong.
Because we stupid.
Now you know that what kind of numbers are there down past 0? Negatives. There are also negative angle measures. We're not going to talk about them, but there are. So when we give the definition of an acute angle, we actually have to say it's an angle that's what? Between 0 and 90. All right? Between 0 and 90. We don't want to just say less than 90. In some books, I know my son, he's in 7th grade now. His math book 2 or 3 years ago actually dealt with those negative angles.
How is there even such thing?
Do what?
How could there be a negative angle?
Because if what an angle is, and when we're measuring angles, what we're actually doing is measuring how much of a turn it is. All right? So if my arm is going from here to here, that's got like a 70-degree turn. And that's the measure of that angle, right? Well, what if my arm all of a sudden went from here to here? Is it still 70 degrees? Now it's going to be like a negative 70 degrees. All right? So it depends on the direction of your turn. And then we're not going to deal with that, but if you get to like physics and higher level maths, then you start dealing with that stuff because you start dealing with the way something's traveling. What's the next angle? Right. We're going to numeric order. It's math class. Right angle. What do you know about right angles?
Measure is 90.
90 degrees. Anytime you see a right angle, what kind of symbol are you going to see in the picture? A little square, something like that. That'll tell you it's a right angle. What other kind of angles are there?
Obtuse.
Obtuse angles. What's the definition of an obtuse angle? 90 to 180. Not less, not more than 90, right? 90 to 180. Very good. You guys learning quick. There's one more angle. Does anybody know what it is?
Isosceles. That's a triangle.
That's all right.
Yeah, but that's the line on the bottom.
There you go. Straight angle. Straight angle. Straight angle is an angle as measured exactly 180 degrees. There's actually one more than this. That would be the negative angles. We're not going to talk about them. So I'm not even going to have you know what it is.
But what happens if it comes on the state test?
It won't. Because it's not part of their standards for this. It's probably like a 5th grade standard or something. But it's not part of
So
the
is-
actual geometry standard.
180 degrees is like the largest degree, right? Because then after that, you just go back around in a circle.
Sort of. All right, but so if I'm doing a 180, that's the biggest angle that we can actually measure with this. We can measure up to 180, and then we can't go any farther than that because if we do that, then it's more than the turn that this protractor will measure.
It'd be 360.
But there are other angles other than 180. I mean, because I can stand here and I can turn that much. Anybody have any idea how much of an angle I just made? 270 degrees. If I turn all the way around, I made an angle of 360. So there are other angles, but not the kind that we're dealing with right now.
Tuck down.
Degree is the amount of turn. Again, just like I was saying, the amount that it's turning. That's what you're measuring. Degree is just the amount of turn. That's the units for angles. The protractor postulate. We talked about the ruler postulate. Guess what the protractor postulate tells you how to do?
How to use
How to use protractor. Do we all know how to use a protractor now?
Yeah.
I hope. We just sort of went over it. That's supposed to say protractor. I hit the edge of my screen and it won't let me make the R. Angle addition postulate. This is important. It's just like the segment addition postulate. Segment addition postulate said this plus this has to equal the whole thing. When you got a picture like this, if I tell you this angle right here, angle ABC is
Same as
20 degrees, and I tell you angle DBC is 32 degrees,
that's wrong.
Could we find angle ABD? How would we find angle ABD? Add those two together. This angle plus this angle should equal the whole thing. That's all angle addition postulate says. One angle plus the other angle should equal the whole thing. Could also be angle subtraction postulate. If I drew this, dang on, I keep hitting the side of the screen. If I drew this, had this, I told you the whole angle was 80 degrees. The whole angle is 80 degrees. This part right here is 20 degrees. What could you tell me about this part of the angle?
It'd be 60.
It's got to be 60. So there you're using subtraction instead of addition. That all makes sense? Easy stuff, right? Learned all this last year. Just boring me to death. Should have liked. Remember, Alyssa, you're going to have to keep reminding her.
I'm not gonna lie to you.
Keep reminding Jaden that
She is very
straightforward.
yeah, she's very true when she speaks.
That doesn't.
There's no like false. There's no false advertisement.
See that? She should have learned by now with her parents that sometimes it doesn't have to be a lie, and it doesn't have to be full truth, the full truth.
Oh, a little white lie.
Congruent angles. Congruent angles are two angles with the same measure. Same as congruent segments. Congruent angles, two angles with the same measure. When we mark angles, we put those little arcs in them. Ethan was talking about the little arcs a few minutes ago. If you know two angles are congruent, if I know that these two angles are congruent to each other, then I put like an arc here and an arc there. And that shows that those two match up. Maybe if there's more angles than that in our picture, maybe I put a little tick mark on each one of them. Anything, as long as they look the same. Peyton wants to put a smiley face in one and a smiley face in the other. That's great. I'll probably think, what in the world is he doing? But as long as they're the same, that means that they're congruent.
I'll put potatoes.
Yeah. Hey Jaden, tell them what they want to know, not what they need to
And
know.
there will only be minor differences
Okay,
between the potatoes.
I didn't say lie to your parents.
No, you're not. Tell them what they want to know, not
No,
what they need to
that's
That's
that
a
might-
lie.
That could be lying.
know. Who wrote the land? I don't know, someone. I never lied to them. I never said I didn't. They don't want to know someone.
No, you did lie to them because you said, I don't know, and you know that you broke the land.
Oh,
Okay, check out the I don't know. Someone.
See, he's a
Someone
parent.
did.
He
So
knows.
say- if you
he
say-
knows what lines are.
Yeah, someone broke the lamp and then you walk away. Now, if they chase you down,
That's obvious. You
I
have
can just
to
use my,
make
my
it deceiving.
speaking of reasoning stuff.
You could just say someone in my
Reason.
class did, I guess.
I broke my door.
I guess. Someone in the family. I guess.
I pulled it off.
angle bisector. Shh. What's an angle bisector?
You bisect the ray in half.
Splits the angle. It's a ray. It's got to be a ray if I have an angle here. The only thing that can bisect an angle is a ray. All right? An angle bisector splits the angle into two congruent angles. Notice how I have these marks. So what's that tell us about
It's the
those
same.
two angles? Somebody name this top angle for me.
MGB.
MGP. Name the bottom angle for me.
PGT.
PGT. What do we know about those two angles? They're congruent. Just had a question Mackenzie.
wait, put your hand up on the thing. Like, you're trying to cover it up, but it goes on your shirt.
Son,
Does every-
it's
does
great
it-
dropping.
Does everybody hear?
I can't go anywhere.
Do we need to go back?
Where'd the
It's
bees
gonna have,
go?
like, few seconds.
Go ahead, bring it.
So ray GP bisects that angle. Ray GP bisects that angle, splits it into two congruent angles. Somebody read this to me while she's finishing up. Angle MGP is congruent to angle TGP. So we know that they have the same measure. So if I told you this top angle was 52 degrees, what would that bottom angle be? 52. What would angle MGT be?
104.
104. Add those two together. On the constructions, on that packet, because we're not going to get finished with it, keep this. When you walk through the door next time, remind me that we didn't get to it, and we'll try to do this. All right? Just something sort of, I don't want to say it's fun, because then Jaden will say something like, hey, it ain't no math fun, or something like that.
Challenge.
What do you want to do with our homework?
And then the very
The homework, just take it with you. We were supposed to do all this part of your homework together, but we didn't get to it, so
So do we have homework?
yes, that's what I'm getting at. This is your assignment. Forget the exit question. This is your assignment.
That's a lot of pages. Or is it just page 44?
Page 44. It looks like a lot of questions, but it's not near as many as it looks like just because
Just
it's,
put a bunch of them separate.
they're all separate. I'm not like most math teachers I know in the past. You're used to getting something like this, right? And it's just easy to write. That's more questions than what I have up there. Let's do this exit question together while we got a minute. Name that angle for me.
Angle 4.
Angle 4, that's the easiest way. Another way.
Angle C.
Angle C, that's the way that I don't want you to do really, but all right.
ACB.
Angle ACB,
And
angle BCA. Make sure you're putting that angle symbol out in front all the time.
well, you said 4 ways, so never.